In this lesson, we're going to be transforming y equals secant x. We're going to graph one period of each of the following, and then for each graph, we're going to answer the following questions. We want to make sure and give the domain range, where the period begins and ends, the length of the period, vertical asymptotes, and we'll also return to talking about amplitude. All right, so how do we graph this function? Well, first of all, let's state a through d. A is 3, so think that we're going to vertically stretch our secant graph. So we'll think about what that looks like in a minute. B is 1, and C and D are both 0. Okay, like what we did for tangent and cotangent, we want to focus on the vertical asymptotes. So for the left vertical asymptote, we're going to take bx minus c and set it equal to, for secant, negative pi over 2. So bx minus c is actually just what's following the secant function. So x equals negative pi over 2. And then the right vertical asymptote on secant is going to be bx minus c again, which is just x equals pi over 2. So just to kind of take us back to the secant graph, okay, this is like tangent. Secant's like tangent in when we're finding our left vertical asymptote and right vertical asymptote. But when you look at the secant graph right here, negative pi over 2 is here and positive pi over 2 is here. So we're really just focusing on half of the period of a secant graph. But once we know how to place in this graph right here in between these two vertical asymptotes, then we can just kind of follow a pattern and do the downward opening graph, etc. Right, so there's nothing to solve here. So I'm going to come over here and start to build the first two vertical asymptotes that'll give me half of the period. I think I'll let 2 tick marks be a pi over 2 distance. So remember, these are the two vertical asymptotes that just are going to contain either the upward or downward opening part of the graph. All right, since we're graphing secant, we know that unless there's a negative in front here, unless A is negative, that the graph in between these first two vertical asymptotes should open upward. And it will, but we also have to tackle where. Where are we going to plot the upward points and the downward points? Well, to get the range, which is what, part B, this is what I would suggest for range. I would write the range down of the parent function. And then I'm going to look at the A and D values to make any changes to the range. Remember, B and C deal with the vertical asymptotes, so those are out of the way. A is a multiplier, so we'd multiply every y value in the range of the parent function by 3. And then if we had any D values, we would add or subtract any of those y values to all these y values in the range. So we don't have a D, so we don't have to worry about a shift up or down. The A has the effect of, since we have a 3A, or excuse me, A is 3, I want to multiply this range by 3. So what's 3 times the range? Well, 3 times negative infinity is still negative infinity. 3 times negative 1 would be negative 3. 3 times this one is 3, and 3 times infinity would just be another infinity. So let's observe this range here. So now we have a bigger gap in our graph. So we only go as high as negative 3, and then we have a gap until we get to positive 3, and then we can draw our graphs. So I think I'm going to let each tick mark be 1 unit. So here's negative 3, and here's positive 3. All right, so now I know where to place my upward part of my graph in between these two consecutive asymptotes, not at 0, 1, but I've been vertically stretched so that graph won't open until I get to 0, 3. Okay, well, that's only half of the period for this function, so I want to move to the right. And when I move to the right, I want to make sure that my next asymptote is the same distance as is between these two consecutive asymptotes. So that's 4 spaces. So here's my next asymptote. And if I wanted to label that, I would just add pi over 2 plus pi. So it looks like that would probably be 3 pi over 2 over here if I wanted to label it. All right, now between these two asymptotes, where do I put the downward part of the graph? Well, not at 0, negative 1. Go back to the range. Back to the range, negative infinity up to negative 3. So halfway between here, that would be as far as I would reach before I had that gap till I can until I can continue my graph. All right, I'll answer the domain after I answer the vertical asymptotes in E. I'll fill in F, which is the amplitude. The amplitude is the absolute value of A. That's 3. All right, the range I've already found. C is where the period begins and ends. Well, the period begins at negative pi over 2. It doesn't end at x equals pi over 2. That would just be half the period. So we do need to know what that is. So the period would not end at x equals pi over 2. We're adding a whole pi here, so this would be 3 pi over 2. And you look back to your parent function because that's where these were on the parent function, and we didn't make any changes to the vertical asymptotes from the parent function. If I were to subtract these two x values here, I would get 2 pi. So for part D, period length. Or, just like sine and cosine, not tangent and cotangent, we would take 2 pi and divide it by b, and b is 1, so we do get back to 2 pi. So it takes a distance of 2 pi to complete one up and down part of the graph. Okay, E says vertical asymptotes. We can start at pi over 2 if we want, or we can start at negative pi over 2. I'm going to start at pi over 2 plus n. Now, I'm not going to multiply n times 2 pi because that means that I'm missing an asymptote. So it's always n times half the period. All right, so n times half the period for secant and cosecant. These 2's divide out, and we just have pi over 2 plus n pi. Same as the parent function. All right, let's tackle number 2. All right, I notice that this is bx minus c. I don't have a parenthesis here, so c is not this value. That's actually our d value. So a is a half, so we're vertically shrinking. So it looks like these parts of the graph will start at maybe a half and down here at negative half. However, we do have a shift down as well, so that's going to get a little complicated, but we'll tackle that in a minute. So a is a half, b is 1, we have no c, and d is negative 1. All right, left vertical asymptote is x equals negative pi over 2, just like tangent, and right vertical asymptote, x equals pi over 2. This will get us one part of the graph, and then we can just finish it based on the patterns that we've seen. Do you have to write LVA and RVA? No. So it doesn't look like I'm shifting this graph left or right. It's just that I'm vertically shrinking it, and then I'm shifting it down 1 too. All right, negative pi over 2, pi over 2. And then I'll count 4 blocks over to my next vertical asymptote. Might as well get that on there. And that's 3 pi over 2. All right, we're graphing secant. Secant typically, unless you shift it left or right, splits the y-axis, half over here to left, half over to the right. Remember, the parent function would start at 0, 1, but we have some changes based on A and D. All right, so let's see if we can come up with a new range before I slip this graph in here. So what we do for the new range is that I'm going to first multiply by a half, and then I'll subtract 1 to all the y values in the range. So I go back to the parent function's range. So first we multiply, and then we subtract. That's the order of operation. So I want half the range. Well, half of that is still negative infinity. Half of that is negative 1/2. I have a half here, and just still infinity. Now I want to take this value, these values right here, and subtract 1 from all of these numbers. So how do I want to show that? I want to do half range which is this line, minus 1. So all I'm doing now is I'm subtracting 1 since I've already taken half of it. Well, negative infinity minus 1 has no effect on anything, so that's still negative infinity. What's negative a half minus 1? Negative 3/2. And then what's a half minus 1? Well, that's negative half. And then subtracting 1 is not going to have any effect on infinity. So it's kind of crowded. I'm going to record it down here. All right, I noticed the gap falls between negative 3/2 and negative 1/2. So we got a gap in there. So I'm going to look at my y-axis and try and figure out where these two would go and then label those tick marks. So I think I'm going to let this tick mark be a negative half. So this is negative half. This is negative 2/2 and negative 3/2 here. So negative 3/2. So our gap is in between these two y values. All right, so now can I sketch this graph? Yes, I know between these two asymptotes that I would start at negative 1/2 and draw my graph upward. Okay, now between these two next vertical asymptotes, I need a downward opening parabola, but I need it to go only as high as negative 3/2. So let's just double check our range. Negative infinity up to negative 3/2. Yep. Gap. Start again at negative 1/2. Yep. And go to infinity. All right, C is where the period begins and ends. So the period begins at negative pi over 2. It does not end at pi over 2. We've got to go over here to 3 pi over 2. The period is 2 pi. Vertical asymptotes are x equals, same as the previous problem, pi over 2 plus half of this period. So n times pi. The amplitude is a half. And we've got the vertical, or the domain. So perhaps graphing these aren't as easy as graphing tangent and cotangent, but if we just go slow enough, we should be accurate. All right, a couple more examples. Let's look at 3. Well, I notice I have a reflection. I notice a b value, and I can't say that this is C until I factor out the 2. So A is negative 1, B is 2. All right, so what we need to do is we need to factor out that 2. I'll put a bracket, and then 2, and then x, and then minus. I know if I distribute 2 back in, I'll get to 2x. What do I put here so that when I distribute 2 to it, I get pi? Well, let's see. If I make this pi over 2, then 2 times pi over 2 would give me pi. So now I see that C is positive pi over 2, always the opposite, and there's no d value. All right, let's tackle the vertical asymptotes first. So let's take bx minus c. I cross those off because when we use them over here, then we don't have to think about adjustments on the graph. So LVA, what are we doing? Secant, so that's negative pi over 2. And then positive pi over 2. Okay, let's add a pi, So a negative half pi and a whole pi is a positive half pi. Let's not divide by 2. Instead, let's multiply by a half. So it looks like I'm going to get x equals pi over 4. And let's add a pi here. So a half plus a whole is 3/2. And let's not divide by 2, let's multiply by a half instead. looks like 3 pi over 4. So the distance between these two, if I subtracted, would be a half pi. 2 pi over 4, a half pi. So we are shrinking horizontally this period. Right, so I'm going to come over here and at least put these two vertical asymptotes on here and try and predict where the next one is. I'm going to let one tick mark be a pi over 4. So 2 and then 3 pi over 4. So 4 pi over 4, 5 pi over 4 must be the end of the period. All right, let's see if there's any adjustments based on A and D. Well, at least I don't have to shift it up or down. Now the range, okay, the range gets multiplied by -1, but all that's going to do is take this upward opening part of the graph and make it come down here. So instead of starting at +1, it's going to start down here at -1. So I'll let 2 blocks be 1 and 2 blocks be -1. So my graph's got to start here. It doesn't start here. It completely reflects to a -1 and opens down here. If you started it here and opened it down, then you're going to have no gap between two consecutive parts of the graph. So this one goes up. This one would normally go down, but it's going to start up here at 1. So the range is the same. It's just that the graphs are now flip-flopped. So let's complete filling in all the information. Yep, still have the gap from -1 to 1. Period begins at pi over 4 and ends at 5 pi over 4. So if I subtracted these two, I'd get 4 pi over 4 or just pi. So the period is pi. Okay, or as a reminder, we could take 2 pi, the parent function's period, and divide it by b, and b was 2, and that does give us pi. The amplitude is 1, just 1, absolute value of A. And x equals, I'll start at pi over 4 plus n times half pi. We usually stack it like n pi over 2. So every half pi, we'll have another vertical asymptote. I think we have one more secant here. This one's kind of interesting. Let's go ahead and state the A through D values. I'm going to go ahead and record the amplitude because I know that's 1. All right, B is pi over 2. There's no C or D values. All right, left vertical asymptote is Bx minus C equals -pi over 2. -pi over 2 for secant. And pi over 2x equals +pi over 2. All right, I'm not going to divide by pi over 2. I mean, I guess I could, but I'm going to multiply by the reciprocal 2 over pi on both sides of the equation. So x equals, notice that you're going to be left with -1, which is kind of nice. The pi is gone. Nice to get just numbers and not something in terms of pi. All right, multiply over here by 2 over pi. 2 over pi, and that's just going to equal +1. That's kind of nice. All right, let's build those vertical asymptotes. So I'm going to let 2 blocks be a -1. So 2 blocks would be a +1. I'm going to go ahead and find my next vertical asymptote to the right here. So 1, 2, 3, 4. 1, 2, 3, 4. So if this is 1, this is 2, this is 3. So it looks like the difference between consecutive asymptotes is 2. Go ahead and put those in there. Okay, we've taken care of B and C through the LVA and RVA. I notice the only thing I need to do is reflect the graph. So the range will be the same. It's just that instead of opening up here at 1, it's going to open down at -1. And I'll let 2 tick marks be that one. Down. And then up here at 1, it'll open up. So that I still see I have this gap in between. X equals -1, but the period ends at x equals 3. And that horizontal distance is going to be 4, so my period is 4. Or remember, we can take 2 pi and divide it by pi over 2. But if you keep change flip, and you put 2 over pi, the pi's will divide out and you'll be left with 4. All right, so vertical asymptotes are x equals, we can start at any of the vertical asymptotes here, -1, 1, or 3. We'll just start at 1, and we're going to add half. We're going to add n times half of 4, half the period. So 1 plus 2n. These are kind of nice because, like I said, when your B contains a pi, chances are you're going to knock out all the pi's in the vertical asymptotes in the domain. It makes it kind of nice. All right, now it's just time to practice.